most well-known companies for U.S. extruders. Those are all the temperature controllers. You have 3 zones. You have a feed zone, you have a melting zone, you have a metering zone. All extruders have at least the 3 zones. That's a heavy-duty gearbox. So that's a Gala. This is a spin dryer right here. So what's happening is the pellets are coming through the extruder, and they're being washed. The water, they're full of water, and they're in the spin dryer. This thing has flights inside. It's a circular chamber, and as the pellets spin, the water is coming out here, and then you'll see the pellets are dropping in another direction. Those are the pellets coming out after they've been dried. And here again, that's a pellet with some kind of an additive to it, ready to be used for some other manufacturing process. Escape. Find that other. And again, this is basically how the strands look coming out of the extruder from the spaghetti die. This is the water bath right here. They're being cooled. And then this is the pelletizer. And then this is the inside of the pelletizer, the guts. And this is the rotor. And these knives have to be super sharp to cut the pellets, and the pellets drop down here. There's generally a cover here. There's a pull roll assembly here. Unfortunately, we don't have anything really good in plastics equipment. Here in the warehouse, the last plant we had was GE Healthcare, where they had injection molders, and those machines were 1,000-ton machines selling for $150,000. Injection motors. Okay. Yeah, I don't even know that. We'll have to talk about that. Did it?
Why is it injection molder capacity?
It's the clamping force. I actually have another video that shows that. If you can, we're not even quite there yet. We're still on extruders. Same place. Basically, an injection motor and extruder does the same basic operation. It takes plastic pellets. You could use the same pellets. It heats them. It melts. But an extruder has a screw that pushes the plastic through a die. An injection motor shoots it. It's a shot size, and it shoots it into a mold. And we'll get to that. So basically, on extruded products, most products that come out that use the plastic pellets, you have a pipe profile, which is drainage pipe or pipes in your house, fencing, plastic lumber, window frames, gutters, wire insulation, plastic film. That's the main products that you manufacture with an extruder. Injection molding, Tony. Okay, so basically you have a hopper, just like an extruder. You have your raw plastic goes in the hopper. You have a screw. You have a motor and gearbox. It's an injection. They used to have a plunger unit, but most people don't use plungers anymore. They have what they call a reciprocating screw. A screw that recips, it turns, it pushes forward, and it pulls back. And then you have, right here, you have your mold, and you have the clamping section. And the tonnage is how much tonnage it goes from when it closes the clamp, and the product is inside. So the plastic shoots into the mold, it closes, and then you usually have the other half of the mold here. It closes, and then depending on how long it takes the engineered product to be manufactured, whether it's a toothbrush or a pen casing or a cap like this. And I have a decent video of it's a little bit on the longer side, but it's a decent video that shows the injection molding process.
Injection molding is the most common method of producing parts out of plastic material. The process involves injecting molten plastic at high pressure into a mold shaped in the form of a part. Once this plastic cools and solidifies, the mold opens and the part is ejected. Injection molding is an extremely versatile process that can produce parts.
It's a very hands-on operation. You have to open the door every time and pull the parts out unless there's a conveyor that drops down on.
Injection molded parts can be simple or complex, and can be solid, foamed, reinforced, or filled. They can be small or large, thick or thin, flexible or rigid. Injection molded parts also lend themselves to endless decorative effects. They can be polished, textured, hot stamped, plated, colored, or clear. No other manufacturing process offers
This is part of a
range
car.
capabilities injection molding provides. Injection molding machines
So it basically, well, yep, Cincinnati, that's what we had in at GE Healthcare. And they're pretty well known. Cincinnati Millicron is one of the probably the best known name in injection molders. You know, it's like any other machine, there's certainly well-known names. So when in the clamping process, thank you again, John. This is what these are parts that John got me from a biomedical plastics company. This is a little, looks like a little scoop or a spoon that's manufactured. This would be the part that's attached to the mold inside, and then this is called the sprue right here, and this is what comes off after those parts that are dropping off, it gets pushed off, it's attached from the mold from this, and then the part that you're saving is attached. This is, so you have the sprue, and then this is attached right here. So what happens is someone has to either break this off, or they have a little saw that's right there by the injection molded, and they cut these, and then this part gets recycled. So then what they do is this goes back to, and we're going to talk about scrap grinders. This goes back to a grinder. It's either right beside the machine, it's sitting right next to that injection molder. As that woman pulls the part off and she opens the door, it's very hands-on operation. She opens the door, pulls the part off, she inspects it, she breaks off the part off the runners and off the sprue, and then this part then goes into a little scrap grinder, and it's either recycled back into the machine and reused if it's virgin material, if it's something that they can reuse. If not, then it goes to another recycler where it's reprocessed again. But most, and again, I'll use GE Healthcare. They had all these little, remember all those, that first deal we did, they had all those little grinders that were set aside. Originally, GE Healthcare had, besides the machine, grinders where they were taking these parts, but then they realized that because of their medical, whatever they were doing with the medical devices, that they were doing incubators and some other medical devices for babies, they couldn't use recycled plastic, so they got rid of all their, besides the machine grinders, and these would go into a bin, and then they would send them off to a recycler so there's nothing wasted on this. It's a very hands-on operation.
Size and complexity, from desk-sized units up to machines the size of a small house. All injection molding machines are a combination of two systems.
See, she's
An
pulling.
injection system
Let me pull that
and
back
a
a
clamping
minute.
system. All injection molding machines are a combination of two systems.
So you can see where she's holding that. She's holding it from the part that right here, where she took it off the mold. And so this is the part that she wants. This part right here, she'll either saw off or break off. And that's why when you look at any plastic part, you have this little bit of this nub here. Sometimes they have a little sander, they grind it down. On a caps, they probably don't worry so much about it. On something that's a nicer finish, like a computer housing, that they're gonna make a little, because you're not gonna want these little nubs on it. But on almost every plastic part you have, you're gonna have some kind of a little part where it was attached to this runner. So she's either gonna take that off and then drop it in the box.
An injection system and
See,
a clamping system.
you can't see, but she's cutting it right now. Let me go back there.
Heats the thermoplastic
It's really dark, but right now you can see where she's cutting
and
it.
the clamping system.
So she's cutting this off, this part right
The
here.
injection system heats the thermoplastic material to its appropriate viscosity or flowability, and then forcefully injects it into the mold. There are two types of injection mechanisms: the reciprocating screw, which is the most common, and the two-stage screw. The main parts of the reciprocating screw injection system are the hopper, a reciprocating screw inside an externally heated injection barrel, a hydraulic motor, and an injection cylinder. Resin material is fed to the injection barrel from the hopper. These hoppers may be filled manually or vacuum fed automatically.
Most big plants have them vacuum fed from a silo
Attached to the top to
because they
remove
use
the
so much
moisture in the
plastic that goes
material.
through there.
As the resin enters the injection barrel,
And very similar to an
driven forward
extruder.
by the rotation of the screw, which is powered by the hydraulic motor. The resin plasticizes or melts as the turning screw drags it towards the nozzle end. This is referred to as drag flow. Drag flow causes the polymer molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the injection barrel. The heating bands bring the material to its final temperature and compensate for the radiation heat loss. The temperature is controlled by 3 thermocouples in the barrel and 1 in the nozzle. The screw consists of 3 zones. The first zone, which is 1/2 of the screw, is called the feed zone. It has a constant flight depth, which forces the material to
And that's mixing the material also as it's deaerated as it's going through it. This is where it's melting.
Has a decreasing flight depth, which reduces the plastic volume. This causes the plastic molecules to rub harder against each other, plasticizing the material. The melt zone leads to the third, or metering zone.
And that's the
The
filling,
metering
that
zone
what
has
fills
a
the injection
constant flight
cavity.
depth, much smaller than that of the feed zone. This section acts as a pump. The tip of the screw has a one-way valve, which lets the material flow only towards the nozzle end. The force of the plasticized material pushes the screw back as it turns. This builds a chamber of plastic in front of the screw. When enough material for the injection shot is melted, the screw stops and pulls back to decompress the material. For injecting the material, the one-way valve closes as the screw is hydraulically pushed forward by the injection cylinder. This sends the molten material through the injection unit's nozzle and into the injection mold. The primary speed and the injection pressure, called the packing pressure, is high, usually around 20,000 psi, but sometimes reaching up to 30,000 psi or higher. A secondary lower pressure is applied shortly after the initial injection. At the time of injection, the material's temperature ranges from approximately 320 to 600 degrees Fahrenheit, or 160 to 320 degrees Celsius. Once the plastic solidifies, no more pressure can be exerted upon it in the mold. The reciprocating screw then begins to rotate again, melting material for the next shot.
So then what happens is, go back. Okay. So then the clamp opens up, and then as you saw in all these videos, there was a woman there, an operator, opens the door, manually pulls out the products, and then again, it comes like this, it's attached, then they have to break off or cut off, or they use a little shear, and they break off the parts, and then they recycle that part. So we'll quickly do, let's see, blow molding, which is how you manufacture bottles.
Before you move on,
Yep.
what's the most important things that you want to ask when someone has an injection molder?
The shot size, which is the size of how much of the plastic will go into the mold, and it's rated in ounces, whether it's 2 ounce, 3 ounce. Usually it's under 10 or 12 ounce. It's a fairly small size, and then the tonnage, that's the clamping force. So you could have a machine that could be 350 ton, 12 ounce. That means that the amount of plastic that goes in, that's the engineered, it's 12 ounces of plastic weight, and then the clamp, how much clamping force to manufacture that. So on a like these caps that John has, this could come on even on a thing like this where you can have maybe 20 caps at one time. So that person takes off, and then it's as big as the mold size. So you have the four arms, the cylinders on either side, two on the top, two on the bottom. Those are called the side rails. And then so your mold is as big as you can put inside that area. So if you have a big part, you may only be able to make one part based on if you have a 36 by 36 inch mold, or you can make 100 of these little things, these little caps.
What's an average size machine? Is it 100 ton? Is it 1,000 ton?
The ones at GE Medical, they were making these incubators. They were most of them were 700 to 1,000 ton.
Is that average? Or
Yeah, for big production. No, average is like in the 5 to 700 ton, 500 ton. 1,000 tons is a pretty good sized machine, and used, that's a $100,000 machine right there. If it's a Cincinnati, if it's something good. And the other thing about injection molders and extruders, it used to be about a 10-year turnover on those. Nowadays, there's so much wear and tear on them that after about 5 or 6 years, they have to tear them down and rebuild them. Rebuild bearings, go through the machines, and so no one's going to want a machine. If you talk a chemical reactor that's 1980s, is not a big deal, or a tank from 1980s. Anything that's older nowadays, anything that's older than maybe 1999, 2000, you're not going to even want it. No one's going to even want to put that in. So anything that we look at, injection motors or extruders, should be reasonably within 10 to 12 years.
Do you have
vintage.
a quick guide for folks about the value? So do you have like a certain dollar per ton? Or is
It's like any other machine. There are people that just deal with injection motors. You have to just go and get some comps. No, there's not a dollar, because it depends on the age of the machine. Is it a Cincinnati? Is it a Van Dorn? Is it a well-known name? Is it? So yeah, it's hard to. I mean, even when I go look at injection motors, I call up and get comps because they change so frequently.
Shot size is adjustable?
No, the shot size is rated on that machine. So if you need a machine that's 250 ton, 3 ounce for that product, you're going to have that size machine. You can't run a 6 ounce on a 3 ounce machine. You can't run 400 ton on a 250 ton.
Can you run a 1 ounce on a 3 ounce?
Can you go lower? I don't know. We'll find out, and I don't know that.
Are there
Good question.
sizes that people are used to in the industry?
Yeah, 3 ounce, 5 ounce, 25 ounce, 12 ounce, 25 ounce, 100 to 150 ton. You don't very rarely see something like 133 ton. It's like 100 ton or 125 ton or 150 ton. It's not usually like an oddball kind of a number.
So if you have a 2 ounce shot size, is that typical on a 100 ton or 200 ton?
2 ounces fairly small. That's probably a 250, 300 ton or less.
So they kind of go hand in hand.
Correct. You're not going to have a 1,000 ton machine with a 2 ounce. Right. You're going to have a 1,000 ton with a 30 ounce machine, shot size.
So how, you said 1,000 ton is like 100 grand?
Yeah, with GE Plastics, we had 4 or 5 machines that were over 1,000 ton, 750 to 1,000 ton, and those were all priced in the $125,000 to $150,000 range.
Compare against, new cost, 4 to 1, 3 to 1?
They're probably 4 to 1.
You gotta remember, most of the money in machines are fairly economical and reasonable. The mold can kill you.
Thanks, Jimmy. I didn't even have any on the molds. The molds, you have to go to a mold maker to make the specific product,
Right.
and so that's usually proprietary to the machine. It doesn't make, because they molds bolt onto the clamp, so it depends on, as Jimmy said, the mold is what costs a lot of money. Those are hundreds of thousands of dollars. That's why the mold, for example, when you do blow molding for bottles, the Coca-Cola shaped bottle, that's,
If we had molds that weren't proprietary, we're selling them.
you almost won't. Anytime you sell an injection motor, people hang on to the molds, or their molds are useless. The molds are proprietary, or unless it's a standard product like a cap.
You can have pharma companies or whatever, some of them would make a standard round bottle like an Excedrin bottle. Bristol Myers in North Carolina had their own bottle of cap production for when they were running Excedrin. But they were just standard white PET bottles, you know, and no markings on whatsoever. And they sold those on bottle makers.
Yep. And then we're going to get into blow molding. A lot of manufacturers used to, and they're not doing it anymore, they would have a blow molding facility right there in their factory. For example, in Clinton, they were doing Vaseline and Pond's cold cream. They had a dozen blow molders right there in the plant. It was like a separate little operation. They would manufacture blow mold the plastic, the bottles, and then they would convey them, or they put them in a tote and they would send them over right to be filled. I know at King Pharmaceutical in Bristol, Tennessee, they had built a plant connected to the plant, and then they would airvey the bottles over, and they had another separate bottle manufacturer. So it's more like a just-in-time kind of an operation, but I think they're getting away from that because it's expensive to do with that operation and also filling and packaging. So then we get into blow molding, which is a similar kind of operation. It's injection molding, but it blows bottles. And I know Jimmy's pretty familiar with them because he's done quite a few of them. The largest manufacturer of probably blow molders is Seidel right now. And basically you have, and I have a video on that, you have an injection molding which manufacturers that will inject a preform. And a preform is a long tubular plastic shape that becomes the bottle, because after it's, you'll see it after the preform is made, it's a long, like I said, it looks like just like a long tube. It's inserted into the machine, and then there's a rod inserted into the bottle, and it blows air, and then the air blows into the mold, and that's how you manufacture your bottles. And I have a video of that right here, actually.
Whether you're buying apple juice or peanut butter, you've probably noticed that fewer products come in glass containers these days. Plastic packaging is becoming more common. Plastic bottles and jars are lighter to carry and leave no shards of glass to clean up if you drop your grocery bag. Many transparent bottles and jars are made from a type of plastic called polyethylene terephthalate.
That's the PET.
An automated mixer combines PET pellets with flakes of recycled PET.
You use less than 10% of recycled
Processed plastic
recycled plastic.
Physical properties, so the recycled content can exceed 10%.
That's standard in the industry.
The PET drops from the mixer into a plastic injection machine that heats it to a piping 600 degrees Fahrenheit. The dry raw material melts into thick and gooey liquid plastic.
So this is an injection molding process right now.
Pressure into a mold. This plastic injection molding process casts pieces of plastic called preforms, starter shapes that subsequent machines will transform into bottles or jars. The molded preforms harden almost instantly, thanks to a built-in cooling system.
So these preforms are now being ejected from the injection molder and dropped onto a conveyor, and they're being conveyed over to the blow molder.
This is another plastic injection molding machine. It uses the same method to make preforms for a different model, 1.5 to 2 liter bottles.
So that's what a preform looks like. That's what this bottle looks like before it's made into a bottle.
The preform's next stop is a machine called a reheat stretch flow molder. In a matter of seconds, it heats each preform just enough to make the plastic malleable. Then inserts a rod to stretch the preform lengthwise, while at the same time blowing in air at extremely high pressure. This forces the preform into a bottle-shaped mold.
They're not all rotary like this. Is that what you're asking?
No, the Does every blow molder come with a preform?
You need a preform. No, you need yes, you need a preform. You need some kind of it's a bubble, whether it's a long shape or it's a little round ball to blow the bottle. Yes,
So you need a preform.
right,
for every-
correct.
There's
Some
some
peop-
injection molders like a Beckham that isn't working with a preform, it's taking a shot, and then it's blowing the bottles from it.
Right from the shot.
Yeah, that comes from a shot, but if you were doing, it depends on what it is, like bottled water, Coca-Cola and everything. It's no point transporting truckloads of made bottles, you ship preforms around, then they blow them on site.
Yeah, another company will maybe inject the
They don't-
preforms.
Unilever Clinton, they didn't have preforms
No, they
there.
were injection shooting.
They were Beckhams. They were
That's
shooting right.
what it was.
Right. And they were shooting the shape, and then that shape was then blown into the form of the Vaseline jar or the ponds.
It's like blow, fill, seal, or sterile, it's the same thing. They get a shot, nozzle comes in, blow forms the container into the mold.
Cold water circulates within the mold to cool and set the plastic almost instantly.
Now the screw part's obviously from the mold, right?
The screw parts for the injection molder, right.
From the mold originally, like that you screw the cap on.
Correct. And these things make 10, 15,000 bottles an hour. They work at a pretty high rate. I mean, thousands of bottles an hour.
A conveyor belt transports the finished bottles to the packaging area.
From here, it'll go to being filled with Coca-Cola or water or whatever the process is. And when you think about a bottle of water you can get for 50, 60 cents, you can imagine how, it costs nothing to make this bottle.
Through an oven.
But then it's nothing to get the water out of the ground either.
Sets the heat level of each infrared oven lamp
Pretty much.
individually, applying more or less heat at various points. The inflow transforms them into peanut jars. It's the same process for this peanut butter jar.
Now that's being shot right in, that's being put right into a mold. It's a different kind of plastics than the water.
The factory pulls samples off the line at regular intervals for quality control testing.
So they do tensile testing, they do crush testing. Right now they're testing it right now to make sure that it's a certain thickness, it'll withstand a certain amount of, it's a detergent bottle.
And capacity. They also evaluate resistance to vacuum pressure because containers
But they have such a good,
are
they have,
sealed after filling.
Simon Smith.
Some models must also be strong
I'm
enough
to-
to resist the pressure of their contents.
Sorry.
Soft drinks, for instance.
All right.
The
We'll have to call him.
recycled material used in making these bottles and jars doesn't come from used plastic.
Let me go get out, because we're running out of time here. So then I have another video of Seidel, but I will blow that off right now. Then we have thermoforming. We'll do that briefly. Thermoforming is also used in blister packaging. That's when you take roll stock and you take plastic roll stock on a winder. I'm going to click on this real quick. And what it's doing is it's pulling the plastic so you have a roll of plastic right here. It's being pulled forward onto a heated die. As the plastic is pulling forward, this die comes down and there's the shape of whatever you're manufacturing. Usually it's like a clamshell could be like a frozen food, those frozen food trays, anything that's plastic with a depth in it, and it's pressing, or takeout containers. You'll see the end result. It's pressing, it's coming down. You can see some of the shapes. So this was thermoform. Now this is still pretty warm, and as it comes down here, you have a tray, or you have whatever product you were just shooting right here. So these are coming down one by one. They're pressed, and they do literally thousands of these an hour. This, it seems like it's a test machine. It's going pretty slow. That's just the die working. Let me go back here. Yeah. Let's see what else we got.
Always pull it up, like with a vacuum, or can then press it down? Form the depth.
It presses it down, the ones I've seen.
Yeah, usually thermoforms or tablets, your unwind is coming across and then it's gonna hit the molds. Usually that's when it gets heated. And then you've got a male mold that fits into a female mold, or a male that comes down into almost like a vacuum chamber where you're evacuating each one of the bottles.
Pulls a little vacuum on it as it
Sucking
sucks the air, and then it hits heated, and then it forms, and then it cools as it comes off.
So then you've got a cup, if you will, or a blister that's ready to have a tablet drop in.
Now, at Dan and Yogurt, and any place that has like a plastic container, they were doing the same thing where they were pre-forming the cups off of a sheet of plastic. They were forming the cup. It was coming in, and then you had, after it trimmed away, there was automatic trimmers. You had the waste. So the waste is the same as this. You have plastic waste in a cup. You have the trim around the bottle, whatever you have that's left over that's cut off. And then you get to granulation. And granulation is what they use for recycling. This is a better picture. So right here is what this is what this is right here. This is called the sprue. This is what connects to the mold, and this is the runner. These are all the parts, and these are some things John brought. These are like molded parts. So all these would be attached to the same, coming off the same arm. Maybe 12 or 15 or 18 of them were made at one time in one mold. Here's another. This is another sprue. This is another runner. 2 parts. These parts look like they connect to each other. It looks like a one-piece part. Literally, you have a person. Then, when this comes off the mold, they're trimming this. So then you have this leftover plastic. You also have right here where they have a little trimmer. They probably have a little bit of a grinder where they trim around here. They have the sprue. They have the runner. And then what do they do with this plastic? Well, you have these grinders. So these are these little grinders, which are 2 to 5 horsepower, called beside the machine grinders. These are generally sitting right next to an injection motor. They're either, the plastic is either chopped up in the, it's fed in through it's either fed manually right into the hopper. In here is a cutting chamber. This is what the cutting chamber looks like right in here. And they measure these. So if someone says 14-inch by 20-inch grinder, that means it's 14 inches this way, 20 inches this way, and horsepower. And that's how you rate the size of the grinder, how big a part you can put in there. And you either have an open rotor or a solid rotor, depending on the plastics, and you have to pull it. So then basically after these parts are then chopped up, a lot of the places have recyclers they blow right out of the discharge right back into the machine. So then this, being virgin plastic, goes right back into the machine, chopped up, and they remelt it and they reuse it again for the next batch. It's a whole continuous process. Then you have big grinders, which generally range from 50 to 250 horsepower, and they're generally in the 20 to 50 inch opening size right here, 20 inches wide by 50 inches this way. And it depends, again, you have a bigger road.